Dear students, today let us discuss about Darcy-Weisbach equation. This equation is most important to determine the friction loss in a pipe. So we are going to arrive at the formula for the loss of head due to friction. Okay, so let us try to apply the Reynolds equation, and with the help of the Reynolds equation we will try to arrive at the head loss due to friction. Now let us consider a uniform pipe, which means the pipe doesn't have any variation in its diameter. It's of uniform diameter. It's not like venturimeter. It's having a normal diameter like constant diameter D. Now the flow is happening from left to right. Now let us say the flow is happening from the left end, like this is entering in and is going to leave away like this. So it's going to have the inlet and the outlet is that region. Now let us try to fix two planes. One is at 1 dash and the other plane is at 2 dash. Now the distance between these two planes, let us call them as L, and the diameter of this pipe as D. And the diameter of the pipe as what? D. Now we are going to measure how much of loss will be there due to friction. What is friction? The resistance force offered to the fluid flow is known as friction. So some students may have a doubt. Then what is meant by viscosity? The viscosity is also the resistance to flow. The difference between the viscosity and the friction is that friction is between a liquid layer and a solid layer, or between two solid layers, whereas friction between two liquid layers is simply called as viscosity. I am telling in a layman term to understand more easily. So what is the difference between viscosity and friction is that in case of friction, it happens between a liquid layer and a solid layer. Okay, now you can see a layer of liquid will be very close to the solid surface. This solid surface, this fluid very close to the solid surface cannot move, and this is because of friction. And this is because of what? Friction. And we assume this is the no slip boundary condition. That is the velocity at the fluid at the wall is assumed to be 0. Okay, so that is the difference between the friction and the viscosity. Whereas viscosity is nothing but the friction between the two liquid layers. In this one, we are going to see only the friction effect. So the flow is happening like this. So what will happen means the frictional force will be acting on the opposite side. It will be acting on the opposite direction to the flow. So let us call this as what our frictional force F1. Okay, if you want, you can call E1 as F or F2. There is nothing wrong. We have to call only as F1. Since many books they are following as F1, we are also following as F1. But you are not happy with the F1 means you can still go with the F. Nothing wrong in that. So that the friction is between this liquid layer and the solid layer. That is nothing but the friction. Now we are going to evaluate how much of pressure head loss will be there because of this friction. Now let us try to first balance the forces which is acting along the section 1 dash and 2 dash. Now let us consider the force which is making the flow to happen along the plane 1 dash is nothing but what we know, the formula pressure equal to what? Force by area. So what will be force? Force will be equal to what? Pressure into area. We know the pressure at 1 dash is 1. So it is P1 into A. Why I am not putting A1? Because A equal to A1 equal to A2. So we can have A alone as a common term. There is no need to have A1 separately and A2 separately. So this is the force which is available for the fluid at the plane 1 dash. So it's nothing but what? The pressure force available at 1 dash is arrived from this formula, and we have this P1A. So what is the force which is available for the fluid at 2 dash? It will be similarly the same formula but with a negative sign. Why it is considered as a negative sign means whenever you are going to take a plane, I can explain it in two ways. Here it is entry to this particular control volume, so it is positive. Here is exiting, so I can put as a negative sign. So simple logic to explain more clearly why P1A is positive and P2A is negative. So inflow is generally considered as positive and outflow is considered as negative. Even if you want, if you can consider this is negative, then this will become positive. Okay, I hope you are very clear why I put a negative sign for the pressure force at the plane 2 dash. Okay, so P1A minus P2A, which will also be, now This force is acting towards the flow. This is acting opposite to this force. Now one more force which will be acting opposite to the incoming force. What is that? Frictional force. It is nothing but what your frictional force. Okay, because the friction will try to oppose the motion. So let us say that is also minus. Why I am putting minus sign? Minus F1 equal to 0. If you are not happy, you can even put F. Nothing wrong in that. So F1 here indicates the frictional force. Why put a negative sign? Because this force also will try to nullify the motion. Will try to resist the motion. So it is like this. So from this term, what we can take? We can take A as common. So P1 minus P2 of A equal to F1. So what is P1 minus P2? P1 minus P2 will be equal to F by A1. That is called this as equation number 1. So how we got equation number 1? We got the equation number 1 by force balancing. What are the forces which are available? The pressure force and the frictional force. The force at 1 is the pressure force, so it is P1A. The force at section 2 is P2A. Since it is outflow, we are considering as negative. Similarly, we are going to consider the frictional force is going to act opposite in the direction of the normal force, normal flow. It is also negative. So from this we arrived that P1 minus P2 equal to F1 by A. So this is nothing but the equation number 1. Let us continue further. I have written this P1 minus P2 equal to F1 by A as equation number 1. This is based on balancing of the forces. Now let us try to apply the Bernoulli's equation. So I am going to apply the Bernoulli's equation between 1 and 2 or 1 1 dash and 2 2 dash. So what is the Bernoulli's equation? P1 by rho g plus V1 squared by 2g plus Z1 is equal to P2 by rho g plus V2 squared by 2g plus Z2. What does it mean? The total head at 1 1 dash or the total energy at 1 1 dash will be equal to the total energy at 2 2 dash. Which means what? The total energy, which is nothing but the summation of pressure head plus velocity head plus diatom head at 1 1 dash will be equal to P2 by rho g, that is the pressure head at 2 2 dash, velocity head at 2 2 dash and diatom head at 2 2 dash. This is fine. If it is like this Bernoulli's equation is based on the fact it is for an ideal fluid, and whenever there is no losses, but definitely the energy at 1 will be definitely more than the energy at 2. Let me tell you like this very clearly for you. If I am going to supply some 100 joules of energy, okay, I am not telling in terms of head and all. For your understanding, I am telling in a layman term. Let the energy available at 1 1 dash is 100 joule. The energy available at 2 will not be definitely 100 joule. Let us say it is only 90 joule. Then what happened to the remaining 10 joules? The 10 joules have been lost because of friction. The 10 joules have been lost because of what? Friction. So this only we are going to find it out. So this Bernoulli's equation is applicable when there is no loss. But practically speaking, there can't be any flow where there can be the loss can be negligible. Generally the losses will be there. So along with this, I have to include a term which is nothing but called as HF. It is called as what? If you want, you can put a capital H or small h, but it's HF. What is HF? The head lost due to friction. That is, I am telling 10 joules now. The 10 joules is nothing but HF. The 10 joules is nothing but what? HF. If you want to tell in meters, you can tell instead of 100 meters, it is 90 meter only. So what happened to the 10 meter? The 10 meter of head has been lost because of this friction. So our aim is now to find out HF. Our aim is now to find the value of HF. I will repeat once again. What does this Bernoulli's equation says is that the total head at a particular section will be equal to the total head at another section. This law is okay whenever there is no losses, L-O-S-S-E-S. But practically speaking, there will be definitely some losses. Now we are considering only the loss due to friction. This point should be very, very well known to you. It should be known to you. Okay. So that is, this value will not be equal to 100 or the energy at 1. So some other energy is also there. That energy is nothing but what? Loss of head due to friction. I hope you got it. Let us proceed further. Now, what is Z1 and Z2? If I am going to consider this as, I am going to consider this as my data mate, then this is nothing but what? My Z1. from this point to this point is nothing but bar, my Z1. Similarly, if I want to take from this point to this point is nothing but bar, my Z2. So Z1 and Z2 are in the same horizontal line because we are assuming the pipe is horizontal. Because we are assuming the pipe to be horizontal, which means Z1 equal to Z2. The effect of gravity is not there. It is going to be only horizontal. So the datum height contribution can be neglected. So Z1 equal to Z2. In a uniform pipe, mostly we consider there will be no more change in the velocities. That is, V1 will be equal to what? V2. V1 will be equal to what? V2. I'll repeat the step. I'll repeat the point. When the flow is happening through a uniform pipe, there is no chance that the velocity will decrease. It's almost same. So V1 equal to V2, which means what? This term can also be cancelled because V1 equal to V2. So V2 squared will also be equal to V1 squared. So this term will be equal to this term. So we can cancel off. So finally, what we got? P1 by rho G minus P2 by rho G is equal to HF. Equal to what? The right hand side is HF. Our aim is to find HF only. Our aim is to find HF. Okay, I hope now there is no need for further diagram. Due to space constraint, I can erase the diagram. So P1 by rho G minus P2 by rho G equal to HF. So it is, if I can take the LCM of this one, it will be P1 minus P2 by rho G is equal to HF. H suffix X, F, that is friction, loss of head due to friction. Loss of head due to friction. So from this, what is P1 minus P2? P1 minus P2 will be equal to my rho G HF. Let us call this equation number as 2. Let us call this equation number as 2. We will continue further. We have two equations now. Equation number 1 and 2. I will write the equation number 1 here once again. P1 minus P2 equal to F1 by A. Let it be called this equation number as 1. So from these two equations, now we can see the left hand sides are same, which means the right hand should also be same. That is the concept, we know that. Okay, so F1 by A will be equal to what? Rho G into HF. So by comparing 1 and 2, since the LHS are same, the RHS should also be same, which means F1 by A will be equal to rho G HF. Now what is here F1? The frictional force. Now I want to tell what is F1. F1 is nothing but what? Frictional force. What is the unit of force? It is nothing but Newton. It is nothing but what? Newton. What is A? Area of the pipe. Cross-sectional area of the pipe, which will be equal to pi by 4 d squared. We know the diameter d, so we can find area also. Now before proceeding further, let us define what is F1. F1, before defining F1, we will come to know what is meant by F dash. F dash is nothing but the frictional resistance. Frictional resistance per unit area per square of the velocity. Per unit square of the velocity. I will repeat once again. What is meant by frictional resistance? Frictional resistance is not actual frictional force. It is the frictional resistance per unit area per unit square of the velocity, which means it is nothing but I can write like this. So F dash by per unit area. So I will come to the unit of F dash first of all, so that we can understand more easily. So F dash is nothing but frictional resistance per unit area per unit square of the velocity. So it is, what is frictional resistance means frictional force. So F is nothing but what? Newton. Per unit area. Per unit area means what is the unit? Meter square. Per unit square of the velocity, which means what? Per meter per second, the whole square. Got the logic? I will repeat once again. So F dash is not a frictional force alone. F dash is frictional resistance or frictional force resistance per unit area. So Newton per meter square. Per unit square of the velocity. So it is meter square. What is the unit of velocity? Meter per second. So what is the per unit square? It is meter per second whole square. So what is the formula I can write is nothing but, if I want to find F1 or the frictional force, is nothing but equal to F dash into I don't want per unit area. I want for the all the area. So multiply by the area. So what is the area? It is pi into d into L. What is this pi into d? This pi into d is nothing but what? My diameter, sorry, my perimeter. What is this length up to which I am going to calculate the resistance? So I know pi d into L. That is nothing but what? My area. Into, it is what? I don't want to per unit square of the velocity. So I want to multiply by the velocity squared. So it is v squared. So it is nothing but what? Velocity squared. So now I will try to make you to understand more clearly. What is F dash unit? Newton per meter squared into meter per second whole squared into what is this one? Area. Area means what? Meter squared. What is this unit? V squared. Meter squared by second squared. So what will happen? This meter square by second square and meter square will get second square will cancel away. This meter square and meter square will cancel away. So I will end up with the unit of Newton. I will end up with the unit of Newton for F1. So the unit of F1 is only Newton, but F dash is not Newton. The unit of F dash is nothing but Newton per meter squared into meter per second whole squared. Okay, that is what I told. Frictional resistance per unit area per unit square of the velocity. So I hope now you got the idea what is the unit of F dash and what is the unit of F and what is the unit of F. Now, so we are going to define the frictional force in terms of frictional resistance into the wetted area. This area is called the wetted area, or where the fluid will be touching the tube. So it is nothing but pi d into L into the velocity of the flow is square. So it is v squared into v squared. So this is the formula we arrived. Now I hope you are clear with the units also. So now I can write once again F1 as F dash into pi into d into L into v squared by, yeah, that's it, into v squared. So what is this pi into d? Pi into d is nothing but perimeter into length into v squared. So this is F1. But I don't want F1, I want F1 by A. So what is F1 by A? Divided by area. F dash into perimeter by area. Or we can put it a common term also. Into length by v squared. So now let us try to find what is P by A. What is perimeter? Pi d. What is area? Pi by 4 d squared. So cancel off pi, cancel off dd. It will be 4 by d. This 4 can be taken to the numerator. So P by A will be equal to what? 4 by d. So instead of P by A, I can replace as what? F dash into 4 by d into L into v squared. So I can see the left hand side F1 by A can be written as what? 4 into F dash into L v squared by d. So that is the thing what I am about to tell here now. I hope you got it. Let us continue further. We can substitute for F1 by A as this term. F dash into 4 into L into v squared by d equal to rho g hf, because we want to equate these two terms. From this, what is our aim? To find hf, that is how much head is lost due to friction. So hf will be equal to 4 f dash into L into v squared by rho gd by rho gd, because this rho g can be brought down. So hf will be equal to 4 f dash L v squared by rho gd. I hope we got it. Very simple mathematical work. Now let us try to find what is f dash by rho. Let us try to find what is f dash by rho. What is f dash? What is the unit of f dash? Newton per meter squared into meter per second whole squared. This is the unit of what? F dash. Okay. So now what is the unit of rho? It is kg per meter cube. Why? Mass by volume. So kg per meter cube. Now what is Newton? Newton is nothing but what? Force. Force equal to m into A. So Newton can be written as what? Kilogram into meter per second squared. So instead of Newton, I can write as what? Kilogram meter per second squared. So write kilogram meter per second squared into meter squared by second squared into kg. I can take this meter cube to the numerator, so it becomes meter cube. Now you see the second square get cancelled. This meter per 4 is there. This is also meter per 4. So this 4 terms will get cancelled. Kilogram get cancelled. So what is the unit of F1 by rho? Yeah, you are right. F1 by rho doesn't have any unit. Okay, it is a constant. So this constant can be called as, instead of this one they are calling as like this, f dash by rho equal to f by 2, where they are calling this f dash because f dash by rho is a constant. I can call this constant as another name. I am calling that constant as what? F by 2, where f is called as coefficient of friction. Got the logic? Why I am telling as constant? Because this doesn't have any unit. When it doesn't have any unit, it should be a ratio or which is a quiet number. So I want to represent f dash by rho as another constant, which say I can call even as f or 2f or 4f, but purposefully I am calling as f by 2. Purposefully I am calling as what? F by 2, where f is called as the coefficient of friction. Where f is called as the coefficient of friction. Now you write as 4 into, instead of f dash by rho, I am going to write as what? F by 2 into L into V squared by GD. Okay, I hope you enjoyed how you arrived at the, this unit is very important, then only you can enjoy the unit of F. Okay, fine. The one more last step we are about to complete now. So what is HF now? HF equal to 4F L V squared by 2dg. This arrival as the expression of loss of head due to friction is known as Darcy Weisbach equation. Okay, this is nothing but our Darcy Weisbach equation. So this equation is used to find the head loss due to friction, which depends upon the frictional resistance. If the length is more, my friction also more. If my velocity is more, then my head loss is also more. That's what I used to tell. If the flow is turbulent, then the head loss due to friction will be more compared to the head loss due to laminar flow. Then it's inversely proportional to the diameter. So if a diameter is very big, then my loss will be less. We can't tell about gravity because the gravity is a constant. So we can see that this head loss due to friction depends upon length and the velocity of your flow. Not only the velocity, the square of the velocity. It will increase many times. So that only when the flow becomes turbulence, the head loss will be very high by 2dg. This particular equation is known as Darcy-Weisbach equation, and this equation where f is called as what? Coefficient of friction. Coefficient of friction. In some other case, I hope you are able to understand this one, very simple only. In some other case, they will even call this as like this, HF equal to F double dash L V squared by 2dg. Now can anyone tell what is F double dash? Okay, F double dash is nothing but you are right, 4F. Instead of this 4F, I am going to put as what? F double dash. Sir, how you put as F double dash? I am simply putting, why I am simply putting? Because 4 is also constant, F is also constant. I am naming one constant in terms of what? Another constant. That constant is nothing but what? F double dash. But no book in the entire globe, I don't feel that F double dash will be there. In most of the books, still they are following only F only. They are following what? Only F. Now this F is not big. I don't know why they are following F. If you are not happy with the F, you can even call it as F double dash. Nothing wrong in that. Naming is only for your understanding. So what I am telling is this 4F can be called as another constant. That constant I am calling as F double dash. But in most of the books, they are not calling us F double dash. Still, they are keeping us F only. But they are calling this F double dash or F as friction factor. As what? Friction factor. And it's not called as coefficient of friction. It's not called as what? Coefficient of friction. Because 4 times of coefficient of friction will be equal to friction factor. If you want, I can write like this. 4 times of coefficient of friction is equal to what? Is equal to friction factor. But why it is getting confused means because they are trying to retain the same term F on both the left hand side and the right hand side. So if I am going to tell 4F equal to F, my mathematical professor will scold me. Why? Because how it can be? Because I can strike off F, it will become 4 equal to 1. It's wrong. But they are trying to name one constant in another constant. That's the only idea. So you don't get confused. If you want, this equation is fine, where here F is called as coefficient of friction. But the same equation can be written as what? F into L. If you don't want to F, you can still have F double dash. F double dash into L into V squared by 2 dg, where F double dash is nothing but 4F, where F double dash is called as coefficient of friction. F double dash is called as what? F double dash is called as friction factor. I hope you enjoyed. You got the logic. Let us take last 2 minutes to explore this particular equation. Here the head loss due to friction is mainly dependent upon F. Why? Because the length of channel you are going to fix it. From which length to which length you want to know the loss. So length is fixed. We also know the velocity. Why? Because you are going to fix the Reynolds number. So you know whether the flow is laminar or turbulent. So you are going to fix the velocity also. That is the flow property also fixed. As well as you know the diameter of the pipe is also fixed. G is also fixed. 2 and 4 are constant we are known. So only the factor which affects this head loss when other parameters are fixed is nothing but your coefficient of friction F. And this coefficient of friction F is given by the formulas which we are not deriving right now. We are directly taking the formula. So this coefficient of friction F is given by 0.0791 by Reynolds number raised to the power of 1 by 4 for turbulent flow. When the Reynolds number through the pipe is more than 4000, it is called as a turbulent flow. So when the Reynolds number is more than 4000, we have to use this formula to find the value of F. Then substitute the value of F over here. You will get the head loss due to friction. Sir, now the flow is not turbulent. Now the flow is only laminar. Let us say the flow is having the Reynolds number of say 1500. Now the formula will be equal to 16 by Re. 16 by what? Re. Where this F is nothing but a coefficient of friction for the laminar flow. No sir, in the problem they have not given what? The coefficient of friction. They have given the friction factor. Then what is the formula? The same F can be found out. Okay, now the formula for the friction factor, now the head loss will be equal to what? F double dash L V squared by 2 dg, isn't it? This F double dash only they are calling us once again F. This F double dash only they are calling us what? Once again F. So now this formula will be called as what? 0.3164 divided by Re power 1 by 4. So compared to this one, how we got this one means you multiply 0.0791 into 4, you will get 0.3164. That's it. So if you know one thing, you can get the other thing by multiplying by 4. How we got F double dash? By multiplying 4 with F. So multiply this 4 with this one, I will get 0.3164 by Reynolds number 1 by 4. Either you can use this formula or this formula. When friction factor is given, you can directly use this formula. When the coefficient of friction is given, directly you can use this formula. Or you can also interchange. You can also interchange the coefficient of friction to friction factor. You can interchange friction factor to what? Coefficient of friction. And one more formula is what? F equal to what? 64 by Re when friction factor is given. How? L is 16 by Re. What I am going to do means here it will be 4 times of F. So 4 into 16 is what? 64. So we got the formula for getting the coefficient of friction or the frictional factor for different regimes of flow. Either the flow is laminar or turbulent. For laminar means this formula. For turbulent means this formula. When coefficient of friction is given. When the friction factor is given, you try to utilize this formula. Both are on the same. I hope now you will be, the main aim of the Darcy Weisbach equation is to determine the loss of head due to friction. When the flow is either laminar or the flow is turbulent. And the corresponding equations have been given. I hope you enjoyed the section and you can go for the practical application of this formula for determining the major losses. The friction losses are generally considered as the major losses. When you are dealing with the minor losses, we will recall once again these friction losses are the major losses in a flow through pipe. Thank you.